the three components you see is a contactor. So what is a contactor? So we will explain. There are three main components of the contactor. First one, the electromagnetic coil. Second is the contacts. Third one is the arc chute. So here you see the company name, and the name is Aton, and it is 3-pole with one auxiliary contact on it. You can see the auxiliary contact NO, and here's the part number. If you turn this, you will see the ratings of the contactor. So it is 45 amps, and so you can use both DC and AC here. Maximum for AC you can give up to 600 volt, and you can use around 25 HP motor, and for the DC side maximum you can go 250 volt DC, and it is 5 HP maximum and minimum 3 HP. Okay, and this is the incoming contact of the contactor, L1, L2, L3, and this is the outgoing contact of the contactor, T1, T2, T3. The meaning is that you can give input from this terminal and you can take the output from this terminal. Inside this we have a permanent magnet wounded as a coil, and the terminal of the coil is A1 and A2. To activate this contactor, the coil should get energized. For energizing the coil, the terminal A1 and A2 should get power supply. So the power supply is mentioned here, 220 volt AC 50 Hz or 240 volt AC 60 Hz. This supply can be given to these terminals. One should be neutral, another should be the supply of this anyone. So this is known as the coil voltage. If we exceed this voltage, the coil inside the contactor will get burned. And here you have the auxiliary contact, NO, 13 NO, and here 14 NO. So this is normally open. In this contactor we have only NO contact, and here you can see NC also. See, you can see NC 31 and 32 NC. Here also you have only the NO contact, NO 13 and 14 NO. Now this is the exposed part of the contactor. Now it has two parts, main moving and fixed end, and one spring to bring back it to the original position when the coil is de-energized. The circle part you see is the contacts incoming and outgoing of the contactor. Now when we give supply on the A1 and A2 terminals of the coil will get energized, as it produces magnetic field, and the upper one will get pulled towards the down. So from this, the contacts on the incoming and outgoing will come in contact with each other, producing continuity between them. Then as soon as we remove the supply from the coil terminals, it will come back to its original position. Now we will see how to test a contactor without giving it power supply. Now how to test a contactor is good or bad. First step is to check the coil resistance. So A1 and A2 are the terminals of the coil. So we will keep the multimeter knob on the ohms, and we will put one probe on A2 and other probe on A1. So it is 613. So the coil resistance is good. Now we will check for this contactor also. So I have put see 1062. Okay, good. Now we will check this one. So it is showing open. So this contactor is bad. The coil of the contactor is open. Second step, this incoming and this outgoing terminal should not have continuity between them. So we will check L1 and T1. So that is, it is open. We will check L2 and T2 open, and L3 and T3 it is open. So before this contactor gets activated or it is energized, incoming and outgoing should not have continuity between them. If it has continuity between them, means the contactor is bad. So the third step you have to do is that you see this plunger type, this you have to push hard down, and you have to keep one probe on incoming and outgoing. Push the hard down. If it gets continuity, means the incoming and outgoing terminals are good. Like this you can check for three terminals. So it is good. See, so this contactor is good. So for testing this contactor, I have given phase on the A1 terminal and neutral on the A2 terminal. I have drawn this from a plug board. So as soon as I switch on, this contactor will get energized and this plunger will pull down. So we will check this. So we'll see the plunger is pulled down here. Now as soon as I switch off, see the plunger came up, the contactor got activated, deactivated. Now how to check the contactor contacts are good or bad? So first we need a multimeter here. I will keep the knob on the ohms mode or continuity mode, and we will turn on the contactor, energize the contactor. So the contactor got energized. Now we will check the terminals between L1 and T1. See, so there is no so you can see the contact coming and going. Now it is L2 and T2 and L3 and T3. So all the three contacts are good, so that you can give incoming supply for the motor or any bigger electrical components, and take the output supply from here when the contactor is energized. So let's check this contactor now. So I have given phase to A1 and neutral to A2. Now I will turn the contactor on. So the contactor is energized. Now we will check the contacts. So you are getting continuity. On the T2, okay. Here also you are getting continuity. Now power contacts are good. Now coming to the auxiliary one, this NC will not get continuity here because the contactor gets activated, and this NC will become NO here. We will check. See, there is no continuity between it, and simultaneously the NO will become NC here when the contactor gets activated. See, so NO becomes NC when the contactor is energized, and NC will become NO. As soon as I switch off the contactor, the NC will get continuity. The NC remains NC, and NO remains NO. Normally open, normally closed. So this is how you test an contactor. It is good or bad. If you don't get any continuity between these contacts, so the contactor is bad. For that you need to open this and clean with the emery sheet. That's a different procedure, so I will explain in a different video.